Hello students, continuing on from what we saw in the last video, when we graph a parabola, one of the things we really care about is where it intersects the x-axis. So here, notice that the y values are 0. So one of the things that we call these are zeros. So the quadratic is equal to 0, that means that y is 0. So the y value equals 0. We see that, of course, over here. And specifically, we say zeros when that happens, when it crosses the x-axis. The reason that we also use this word roots is that we don't always cross the x-axis, but a parabola always has two roots. So let's think about why we don't always say two zeros, but we always say two roots. So if we think about the way that a parabola can look, and of course we saw that in our Desmos, we saw that a bunch, that as we moved our A, B, and C, our parabola moved all over. So I'm going to hide this one, and I'm going to get rid of that axis of symmetry. So as we move our parabola around, here we've got no roots at all. Sorry, we have no zeros at all, but we still have two roots. It's just that they're imaginary. They're somewhere in the complex plane. As we move our graph around, now we have two zeros, and then we also see that there's a time where we might have just one zero. And here we say that the roots are repeated because it's the same one occurring twice. So coming back to our notes, we have the possible solutions, one real solution, and this is a repeated solution. So we can call this, let's move that up a little bit more, a repeated root. Two real, often we distinguish here that they're distinct. So two real and separate, because here there were two real, it was just repeated. No real solution. This is a way of saying that there are two distinct imaginary solutions. So those are our different types of solutions that we can have with a quadratic. Here, we would say that this is a 0. These are zeros. Over here, this one doesn't have any zeros, but it still has two roots. They're distinct and they're imaginary.